gradient on the chapter vector. So I have a scalar quantity phi, which is given as x, y, z plus 4x square y, z plus x, y, z square. I have to find out gradient of phi. Again, I repeat, phi is a scalar quantity at the point 1, -2, 1. So to find out this grad phi, we know that gradient of a scalar quantity gives a vector. So the result will get as vector. So how does it work? So I write this operator as I del x plus j del y plus k del z. And then the scalar quantity x, y, z plus 4x square y, z plus x, y, z square. So how does this operation take place? Each quantity of the first bracket, that is I del x, del y, del z, will act on the scalar quantity which is given in the second bracket. So how do I write it? I del x of the scalar quantity, that is x, y, z plus 4x square y, z plus x, y, z square. Then I have j del y, which will also act on the whole scalar quantity x, y, z plus 4x square y, z plus x, y, z square. Then I have the k del z, x, y, z plus 4x square y, z plus x, y, z square. Okay. So what's the rule, or how do you do the derivative? Remember, this is a partial derivative. So when you have this del x and operates on this whole bracket, while doing it, the x, it will undergo derivative with only x, or the other terms like y and z will remain constant. So in the, for del x, x is the quantity which will be derivative, and yz will be constant. So del x of del x by del x gives 1. So from the first term, the output will be yz. Similarly, for the second term, x square, if I do the derivative, we will get 2x. 2x multiplied by 4yz gives 8xyz. Similarly, the third term, again the derivative operates on x, that is 1, del x by del x. The constant part is yz square. So the answer for this del x, for the whole quantity, scalar quantity, I have yz plus 8xyz plus yz square I cap. Similarly, del y, only y will act, the other quantities will remain constant. So I have xz 4x square z plus xz square. Similarly, xy plus 4x square y plus 2xyz k cap. When I substitute, now this is not over, this is a vector quantity after getting grad phi. But now the question says that you have to find out the value of this grad phi, which is a vector quantity obviously, because you have this I, j and k components. But you have to substitute the value of x as 1, y as -2 and z as 1 and get the value of the vector grad phi. So when I substitute these values, I have -2 -16 minus 2 I cap. When I substitute this x, this is y, this is z. Then I have 1 plus 4 plus 1 j cap and minus 2 minus 8 minus 4 k cap. So the grad phi value at point 1 minus 2 minus 1 gives me minus 20 I cap plus 6 j cap minus 14 k cap. So that's the answer. I will consider another problem from the topic gradient. So let's write down the question. Show that gradient of r to the power of n is equal to n r n minus 2 r vector. So r, when I don't write r with a vector sign, that means it's the magnitude of the vector r. So what is vector r? It is x I cap plus y j cap plus z k cap. And what is magnitude of r? I don't put arrow on the top, which means that it's the magnitude of vector r, and it is given as root over x square plus y square plus z square. Or you can write down this as x square plus y square plus z square to the power of half. So you can write down in this way also. X square plus y square plus z square to the power of half instead of the root sign. So how do I write then r to the power of n? I can write down this as x square plus y square plus z square to the power of n by 2. Because if r is to the power of half, then r to the power of n is x square plus y square plus z square to the power of n by 2. Okay. Now I start operating this left hand side, calculating this left hand side. Grad r to the power of n. Remember, r to the power of n is a scalar quantity. This is a scalar. You don't have vector here. And when you do this grad of r to the power of n, the output, which we have to prove basically, gives a vector. Remember, there is a vector sign here, r vector. So how do I write? I write this way. I del x for the operator, j del y plus k del z on r to the power of n. So r to the power of n is x square plus y square plus z square to the power of n by 2. So again, like the previous problem, every quantity of the first bracket will act on the second term, that is r to the power of n, which is a scalar quantity. So del x will act on the scalar quantity, del y will act on the scalar quantity, del z will act on the scalar quantity. So how does it look? I cap. So when del x act on this, how does this derivative act? It will, or how does the derivative result come out? So n by 2, the power first comes, n by 2. Then x, this term, x square plus y square plus z square to the power of n by 2 minus 1. And then the derivative inside this bracket. That means derivative will act on x square plus y square plus z square. Because this is del x, it will only have the answer for x square, which is 2x. But the rest y square plus z square will be 0. So I have multiplied by 2x. And this del x work is done. So similarly, I will have for the del y, that is j cap, second bracket open, same thing, n by 2 x square plus y square plus z square n by 2 minus 1. But now I have del y operating on the whole bracket inside x square plus y square plus z square. So x square it will give 0, y square it will give 2y, and z square it will give 0. So this is the part of del y. Similarly for del z, I have n by 2 x square plus y square plus z square n by 2 minus 1, and then del z will act on x square plus y square plus z square. X square 0, y square will give 0, z square I will get as 2z, and the bracket close. Okay, so this 2, n by 2 and this 2 might cancel. This 2 and this 2 might cancel. This 2 will cancel. So what I have now? Grad to the power of r to the power of n. I can take n, x square plus y square plus z square to the power of n by 2 minus 1 common, and I have, from the first bracket I have x I cap, second bracket I have y j cap, and third bracket I have z k cap. So this quantity comes out, you can take common from every term, from the I bracket, j bracket and z bracket. So grad r to the power of n I can write down as n, this x square plus y square plus z square. So if I have r as this, then r square, what do I write? I can write x square plus y square plus z square only. So this bracket x square plus y square plus z square I can write down as r square, and this to the power of n by 2 minus 1 I can write down as n minus 2 by 2, and this third bracket x I cap plus